Now we are going to start with the new chapter, that is the chemical kinetics. But before we do that, I just want you to know that where this chemical kinetics is being used or what is the purpose of studying this chemical kinetics. So this chemical kinetics is actually concerned with the chemical reaction. So before we start with the detailed study of the chapter, I just want you to be aware of that what is the chemical reaction. So as you all know, when we talk of chemical reaction, so this means that we add certain substance and those substances just you can say undergo a combination, a decomposition or a simple displacement or any kind of further reactions, that we can say that they just you can say the old bonds are broken and the new bonds are formed, and then they just you can say undergo a chemical change and definitely they form a product, that is the AP. Right. So the substances that react actually are considered to be reactants. So in this given example, A and B are reactants and this AB is product. As I took in this example, I took two reactants and I made one product. So it is not always, as you all know, that it is not always that reactant is always going to be 2. It can be 1 also, it can be more than 2 also, and likewise the number of product can also vary. The product can be 1, can be 2, can be 3 depending upon the reaction, right? So but in this example I just shown you the chemical reaction, that is the type combination reaction. That is why I took 2 reactants and I formed one product. And like if you are taking some other example, you can do accordingly the type of the reaction. Just consider the type of the reaction and you can just take any example. But our concern is that at this moment I just want you to know that what is the chemical reaction. So I think you got it in a correct manner, that chemical reaction is actually a process in which few substances undergo a chemical change and those substances are called as reactants. That means they react among themselves and then that means their old bonds are broken and new bonds are formed, due to which they lead to the formation of a new substance, that is the product. So this is actually the chemical reaction, as you all are studying this chemical reaction from the last classes as well. Now when we talk about chemical reaction, our major areas of concern are 3 areas. The first area is that, like when we talk of this chemical reaction, we consider about its feasibility. Right. So what is the feasibility? See, whenever certain chemical reaction is taking place, you should be aware of its feasibility. Feasibility means that whether that reaction will take place or that reaction is not going to take place. So our major area of concern is that whether the reaction is going to take place or whether the reaction is not going to take place. Suppose I have an example for you, as if we add copper to zinc sulfate solution, and in the other reaction what I am doing, I am adding zinc to copper sulfate solution. So as you will see that this reaction is not going to happen because the copper is less reactive than zinc, it is not going to displace zinc, right? So what we get to see as a result, we get to see nothing. So that means no reaction take place. But in this reaction, as zinc is more reactive than copper, so definitely the reaction is going to take place and it leads to the formation of zinc sulfate and copper. So that means like by taking this example, I just showed you that it is not always that all chemical reactions are going to occur. There are few reactions that occur actually and there are few reactions which do not occur. So that means some reactions are feasible. As you can see, zinc plus CuSO4 is feasible. The reaction is taking place. But when we talk about copper and ZnSO4, reaction is not feasible because reaction is not taking place, as the reason can be anything. Like in this, the reason is that the copper is less reactive, cannot displace zinc from its solution. So the reason can be anything. One more example I have for you. See, I have water. I just want to break water into its components. So as I know, water is formed of HNO, obviously it is going to break into H2 and half O2 if we balance it, right? And similarly, if I want to form water, what I am going to do? I am going to react the H2 plus half O2 and it will lead to the formation of water. As the both reaction appear to be same, but actually when we talk about its feasibility, the reactions are not same. Like just look at the board, how they differ. See, in the first reaction we are breaking up into its constituents. So breaking of water into constituents is not a spontaneous reaction. That means you have to supply you can say energy from an extra source in order to carry out the chemical reaction. So that means the reaction is not spontaneous. That means the reaction is not going to occur itself under the given set of conditions. You are going to supply it some source energy from some source, then only the reaction can happen. Like in this case, if we want to break the water into components, we have to pass the electric current, right? So that means the electric current is the source of energy, external source of energy, which is just making the reaction happen. So otherwise this reaction is non-spontaneous, it is not feasible. If you don't supply it with energy, nothing is going to happen. That means the reaction is not feasible. But when we talk of this, that hydrogen plus half O2 leads to formation of H2O, it is a spontaneous reaction. It do not require any kind of initiation or any kind of energy which is to be supplied from external source. It will happen as such. So that means this reaction is spontaneous, it is feasible, it is going to happen under the given set of condition by itself. But when we talk about this, it is non-spontaneous, it is not going to happen until and unless you will force it to happen. Like I supply it with electric current, then only the reaction happened, otherwise the reaction failed. So that means our first concern is that the reaction is going to take place or not, that is the feasibility. So when we if we want to know about the feasibility, see, there are millions of reactions which are taking place in nature, right? So it is not always that you must be aware that yes, the reaction is going to take place or yes, the reaction is not going to take place. There can be any reaction in which you are not definite about the result, that whether the reaction is feasible or not. So we learn, we come to know about this feasibility from the thermodynamics. This is the reason we study thermodynamics. So according to this thermodynamics, when the delta G is less than 0, that means the reaction is feasible, right? So from this delta G less than 0, we come to know, that is from the thermodynamics, about the feasibility of the chemical reaction. So this is the reason that we study thermodynamics, because it makes us aware about the feasibility of the reaction. Now this is the first concern, like when we are talking about the chemical reaction, our first concern is the feasibility, that I already told you. Now the second concern, when I talk about the second concern, our second major concern about the chemical reaction is that the extent to which the reaction will proceed. It is the extent to which the reaction will proceed. And if I say the extent, this means that obviously A and B are going to form the AB product. But how much AB concentration of AB is just going to react, and how much concentration of AB will get at the end of reaction? Will all A and B combine with each other and they will result in the formation of AB? Or we'll be left with some concentration of A and B. So this is, we come to know about this concept, that this is called something as extent of, you can say, the chemical reaction. And when we talk about the extent, you know that from which physical phenomena we come to know about the extent to which the reaction is going to take place. That is the equilibrium. So we study equilibrium because it makes us aware, actually aware about the the extent to which the chemical reaction is going to proceed. So how you come to know from equilibrium? You know, we have already done with equilibrium, but still for this moment I'll just recall that. See, we write equilibrium constant expression, right, and that is written as K is equal to concentration of product divided by concentration of reactant. More is the value of this K indicates that more product is favored. That means the reaction is going to proceed in a forward direction. And when this value of K is less, that means the reversible reaction is, you can say, is favored. So that means from equilibrium constant expressions, we get to know about the extent to which the reaction is going to take place. So this is our second concern. When we are studying any chemical reaction, first is feasibility, that we should know that whether the reaction is going to take place or not. Second is the extent to which the reaction will occur. Third, our major area of concern is time taken by reaction to occur, right, and this is something called as rate of reaction. So our third concern is the rate of reaction. That means how much time actually will be taken for the reactants, that is the A and B, to get completely converted into the AB. So you know, like this rate of reaction we come to know from the chemical kinetics. So this is the reason we are here to study this chemical kinetics here today. So chemical kinetics is actually a branch of chemistry that deals with the study, or you can say that just reveal the time which is actually taken by the reactant to get completely converted into the product. So this is the reason we study the chemical kinetics. Now we are just taking up the chemical kinetics in detail. Just look at the board carefully.